So, hey everyone, I am going to record today's lecture on determining Z critical values, as well as how to write your results in APA format. Great. So first I'm going to start by reminding you of the steps involved in hypothesis testing. Then we'll talk about what a Z-crit is, or a critical Z-score is, because that's involved in the lab that you have to complete for this week. And then we'll also go over how to write your hypotheses and your results in APA format, which is also included for your lab. All right, so the steps in hypothesis testing. Remember, first we have to specify the hypotheses, set the criteria for inclusion, collect the data and compute sample statistics, and estimate the probability of the hypotheses, and then draw a conclusion. So today we're going to go back and talk about step 2 and step 3 so that you know how to establish a Z critical score. All right. So I'm going to continue with the same example that we used in last class, where we wanted to see whether the IQ of WU students was higher than the general population. If you'll remember, we recruited a sample of 25 WU students and we calculated their mean IQ scores. We know that the average IQ score, the average IQ score for the population is 100 points. So our null hypothesis was that the true population mean is not different from 100 points of WU students. And if the null hypothesis is true, then the sample mean would be close to 100 points, and the sample mean far away from 100 points would be improbable. These are what we will be calling critical regions. And we determined an alpha level of 0.05. That's usually what we use in psychological studies. So this indicates a probability value that's low enough that we're willing to reject the null hypothesis. And we usually set this at 0.05. So that's what determines the critical value. All right, so again, we collect our data, we compute our sample statistics. We have our sample size of 25, a mean of 106. The mean, according to our null hypothesis, was 100 points. We're comparing to the average score of an American. For our effect size, we determined it's 6 IQ points. So does this mean that we can reject the null hypothesis? So we have to determine our p-value first, and we did this last class. So we calculated the standard error. So that's standard deviation over the square root of your sample size, which equals 3 points. So how many standard errors away from 100 is 106? So it's 2 standard errors away from the null hypothesis mean. So the probability of getting a sample mean that is greater than 2 standard errors away from the true mean is here, 2.28. And that's how we determine our p-value. So if the null hypothesis is true, there's only 2.28% chance that we would get a sample like ours, or our p-value would be equal to 0.0228. So we determined that this alpha level was the p equal to 0.0228 was lower than our required alpha level, which is 0.05. So we established that the true population mean is different from 100. So the sample mean was significantly different from 100. So how else can we draw a conclusion? We talked about the p-values, but let's talk about the Z scores and Z critical scores. When we're looking for a Z critical score, we look at the unit normal table. So this is one screenshot of a unit normal table. This is another screenshot of a unit normal table. This unit normal table I'm going to be using to demonstrate to you what our Z critical score is or should be when our alpha level is set at 0.05. So in order to find our Z-crit score, we look at the tail value, and we're going to look at 0.05. Because we're rounding to the second decimal point, we would round this up to 0 and this to 5. So this is the closest value to 0.05. So our Z-crit value is 1.65. So if our Z-score is greater than or equal to 1.65, then we can reject the null hypothesis. If we set our alpha level to be 0.01, so we had a more stringent criteria for rejecting the null hypothesis, again, we would go to the tail value. We would go down here. Again, we would round to the second decimal point. So this is closest to 0.01. So if we wanted to reject the null hypothesis, our Z critical value would have to be greater than or equal to 2.33. These Z-scores are called critical values. These are the values that your Z-score of your sample must meet or exceed in order for you to reject the null hypothesis. All right, so we said that students at WU have a higher IQ than the average American. The mean of our population is 100. This is the IQ scores of Americans. And the mean of our sample of WU students is 106. The way that we calculate a Z-score here is we take the mean of our sample, we subtract it from the mean of the population, and then we divide it by the standard error. So we take 106, the score of IQs, the IQ scores of WU students, we subtract 100 from it. This is the mean of the population, so Americans, and we divide it by the standard error, which we determined to be 3. So 6 divided by 3 is 2. Our Z-score is exactly 2. All right, so we got a Z-score of 2. Let's say our alpha was set at 0.05. So what's our Z-critical score? Let's look it up. Again, when our alpha is set at 0.05, our Z-critical score is 1.65. So our value, our Z-score for our study has to be greater than or equal to 1.65. So it's 2 greater than, less than, or equal to 1.65. It's greater than, so we met the Z critical score, we exceeded it, so we can reject the null hypothesis. So what we can say now is that WU students' IQ is statistically significantly higher than the average American's IQ. But when we say statistically significant, what does that mean? So that means that the obtained data that we have differs from what you would expect, or what would be expected if your null hypothesis was true. Just because something's statistically significant doesn't necessarily mean that the findings are important or that the effects are large. And we will go over that in future lectures, but this is all you need to know for now. So you must include the following when reporting your results. So you have to include the description of your results in everyday language, include your descriptive statistics, include the test statistic, which in this case was a Z-score, and then you also include your p-value. So this is how you would report the findings from what we did today. Students from Western Oregon University scored significantly higher on an IQ test, a mean of 106, see if you can plug in the standard deviation, than the general public, a mean of 100, see if you can plug in the standard deviation. Z-score of that difference is 2.0. The p-value was 0.0228, which I rounded to 0.023. All right. So that's all you need to know to complete the lab. So I will post that up and give you some more time to complete the lab, given that I posted this a little later than I anticipated. All right, so I hope you all have a great weekend, great Thursday, great Friday, and I will see you next week.